Hello and welcome back. In this video we discuss about Newton's second law of motion. We have seen earlier that if the net force acting on a body is zero, the body will remain in its state of rest or uniform motion along a straight line. In this video we will discuss the effect of a net force acting on a body. When an object is at rest acted by a net force, it will start moving and its velocity increases with time. When a body moving at constant velocity is acted upon by a net force, its velocity changes. Since the velocity is a vector quantity, a change is possible through changes in its magnitude, direction, or both. Change in velocity will depend on the direction of net force acting on the body. In both these cases, the object accelerates due to the applied force. According to second law of Newton, the acceleration of an object is directly proportional to the net external force acting on it, and it is inversely proportional to the mass of the object. The second law states that the change of motion is proportional to the motive force impresses and is made in the direction of the straight line in which that force is impressed. Mathematically, this can be written as F equals ma, where F is the net force applied and A is the acceleration vector of the body, and mass of the body is m. To better understand this concept, let us consider a simple problem. A block of mass 10 kg is resting on a frictionless floor, is pulled by a force of 20I plus 30J Newton. This is equivalent to 36 Newton acting 56.3 degrees from the x-axis. What is the acceleration of the block? The first step is to find the net force acting on the block. In order to do that, we have to identify the forces acting on the block, which is the weight, reaction, and applied force. If we add all these forces together or take the vector sum, we get the net force acting on the block as 20I Newton. Net force divided by the mass of the block will give you the acceleration. Let us consider another problem. A block of mass is resting on a frictionless table. Calculate the acceleration of the block. The first step is to find the net force, then the net force divided by the mass of the object will give acceleration. Finally, we will discuss a few other representations of Newton's second law. Since acceleration is the rate of change of velocity, the equation F equals to ma can be written as F equals m times dv by dt. Rewriting this as F times dt equals mass times change in velocity, the first term is called the impulse impressed on the body, and the second term is called the change in momentum. Therefore, another statement applicable for second law is the change of momentum of a body is proportional to the impulse impressed on the body, and it happens along the straight line on which that impulse is impressed. This is equivalent to the statement that the net force is equal to the rate of change of linear momentum. Thank you for listening. Keep watching tied-up video demonstrations of basic physics concepts.